So I have all of my files set up on this remote server where I have a different folder for each different depth that I placed the electrode in the model. And so I have a different model file, completely different setup for each simulation. And basically what we have in each folder is, ignore, these are all results because the simulations take quite a few hours to run each one because the model is so high resolution. So I've already included the results in all these folders, and basically I have a file which shows, or which contains the model, and this program will just show us a 2D slice of the model, and you can see that I've applied a different material index for each voxel within the simulation. So here's a slice of the hippocampus coming into view, and you can see the electrode, and we're just looking at the electrode on the right. And then so I have one of those for each model, and then I have a file which contains information about each material index and what the resistivity and relative capacitance would be for that material index. And then I have the current information, which just says which nodes it's going to go through. So in this case, I'm only using the middle two electrodes, and I'm applying a biphasic current pulse. And then I have a ground plate located on top of the electrode. And finally, I have a file which basically just contains the amplitude of the current at each time step. So I run this, and I run this simulation just using the admits method, which just solves for the voltage throughout the model given the current and the resistivity between each node. And it creates all of these V-average and J-average files, which then contain the voltage at each node in the model at each specific time step. And what I'll do then is I'll compress these files and download them to my local machine for more viewing.